Hello guys, my name is Bob. Welcome to the Excel Math channel. And in this video, I'm going to talk about expectation and variance of a discrete random variable. To me itself, when we define expectation, is a little bit different because um, even though it has pretty much the same meaning as the word called mean. Normally when we talk about mean, okay, let's say for example we have four values, 4, 5, 9 and 3. When we take the mean, we actually sums up the values down here, which is 4 plus 5 plus 9 plus 3, and then we divided it by 4, right, to find out the mean. So what does this do? Okay, this actually assumes that each value itself is given an equal weightage. All right. Whereas for expectation is a little bit different from the word mean, because when we talk about expectation, we know that there are certain cases, a lot of cases, whereby the values are allocated different weightage. All right. So let's look at this particular example. Same thing, we talk about X as the outcome of a coin toss, in which the numerical value 1 will represent the outcome of a coin toss to be head, and 0 represents the outcome of the coin toss to be tail. We assign the probability of getting a head to be 0.4 and the probability of getting a tail to be 0.6. So for this coin toss itself, is not a fair coin toss. All right, it is biased towards the outcome of getting a tail. Okay, and then we learn about this probability mass function, which is a particular formula in which if you were to substitute the numerical value of the outcomes into the equation itself, we can get the probability. So for this case itself, my p is actually 0.4 to the power of x, and my 1 minus p is 0.6 to the power of 0.6 and to the power of 1 minus x. So this is the general formula in which if you were to sub in a numerical value 1 into the equation, you get the probability 0.4, and if you were to sub in x is equals to 0, you will get a probability of 0.6. All right. So based on the formula of our expectation, so the formula of expectation simply means that you take the sum of x, all right, of the numerical value of the outcome times their probability. All right, so what does it do? So basically this formula itself, you take the numerical value times the probability of the outcome itself, and then you sum it all up. So for this particular example, to find the expectation, which is EX, we usually denote it as EX itself. It is equivalent to the sum of X times PX. So for this case itself, my numerical value 1 takes on the probability of 0.4, okay, plus the numerical value of 0 takes on the probability of 0.6. All right. So for this case itself, it will just be 1 times 0.4, and the answer is actually 0.4. So which means that my expectation of the value of the value itself is actually 0.4. All right. So my expected value out of a experiment of few number of trials, right? Maybe 100 number of trials of outcomes, will give you an expected value of 0.4. So that's what it means by expectations. All right. So this is the first part about the video. The next part we're going to talk about is called the variance. All right. So variance, basically, it actually means the measure of dispersion of the data set itself. So for variance itself, we will have a formula to calculate the variance. So we usually denote variance of a random variable by var x, and this is equivalent to the expectation of x squared minus away the expectation of x, the whole thing square. All right. So applying this this particular formula itself, so to find the expectation of x squared is just basically equivalent to the sum of x squared times the probability mass function, which we denote it as px. All right, so for this case itself, my x squared is 1, all right, and then the probability is 0.4 plus if we were to square the numerical values for the tail itself, it was 0 square, it will be 0 square, all right, times the probability, which is 0.6, and that gives me the expectation of x squared to be 0.4. All right, so to calculate the variance, which is actually the measure of dispersion of my random variable x itself, is just taking the expectation of x squared, which is 0.4, minus away the expectation, the whole thing square, which is 0.4 square, and this is 0.16, and my final answer for my variance is actually 0.24. So for this case of this discrete random variable, we have the expectation, which is the sum of x times the probability mass function, which is 0.4, and the variance itself, taking the expectation of x squared minus away the expectation of x the whole thing square, that gives you 0.24. All right. So the thing about the random variable is that every random variable has an expectation and the variance itself, and from there we will need it because that actually defines the type of random variable. Okay, I hope this tutorial is clear enough to explain about what's the meaning of expectation, what's the meaning of variance, how do you get your expectation, how do you get your variance. All right, that's about it from me. I'm Bob, signing off from here. If you guys have any problems, do comment in the comment section below, and I will see you in the next episode.